This is the last question on the 6.3 class notes. Okay, so we want to find the area of the roof on the square gazebo below if each roof ridge is 10 feet long as shown. Okay, so the shape here is going to be a triangle. So what I need to find is the area of a triangle. And we actually know a couple different formulas for the area of a triangle. One is, hold on, I got my pen, that the area is 1/2 the base times the height, or we can use Heron's formula. Okay, we should get the exact same result either way we do it. Okay, so let's look at what we actually know, and then we'll decide which way we should actually do this. Okay, so it tells me that it's 48 feet all the way around, okay? And since it's a square, which I get from that piece right there, I know that each side is the same length. So I know that one side will be 48 divided by 2. I'm sorry, divided by 4. Change this. Okay, so each side, that means, is 12 feet long. Okay, so I can label this 12. Okay, so if this is 12 along here, that means I also know that it's going to be 12 up there. So if I make this piece right here is also 12. Since this is 10 feet, okay, this roof ridge is 10 feet. I also know this roof ridge is 10 feet. So now I actually know all three sides of my triangle, in which case I could use Heron's formula. So right now you could actually just say, oh, I want to use Heron's formula. And if you remember to use Heron's formula, it's S is the half perimeter, right, of the triangle. So that'll be 10 plus 10 plus the other side, which we know is 12. And then we're going to divide this by 2. Okay, because remember we're looking for the half perimeter. Okay, and then that gives me 16. Oops. Okay, so now I can plug that into Heron's formula. So my area is the square root, right, and it's S times the difference between S and each of the lengths. Okay, so this will be 16, and then I have to take 16 minus 10, okay, and then 16 minus 10 again, because that's the second side. And then I'm going to have 16 minus the third side, which is 12. Okay, and when I get all done, right, that should, this will give me an area of 48, and we are in feet, so it'll be 48 feet squared. So 48 feet squared. But remember, that's just for one of the triangles, and there's 4 of them. So I need to multiply this by the fact that I have 4 of them, which gives me a area of 192 feet. Okay, so that's the first way I could do this problem. Oh, sorry, 192 feet squared. The second way I can do the problem is I could actually go through and find the height right here of the triangle. Okay, so if you look at my triangle, and I can put in the height of the triangle, and that would be this distance right here. Okay. Now, if you remember about isosceles and equilateral triangles, if you draw in the altitude of either an equilateral or an isosceles triangle, where on isosceles triangle it has to be the altitude that goes to the base, where the base is the side that has a different length than these two. So if these two sides are the same, and you draw in this altitude, it actually cuts this side right here in half. So I actually can label that side 6. Okay, because we know the whole thing is 12, that's going to be half of it. I can use Pythagorean theorem to find the length of the green line. and we'll just call that green line B for now. Okay, so that tells me that B squared plus 6 squared is equal to 10 squared. Okay, or that B is going to equal 8. Okay, so the height of that triangle is 8 feet. Okay, and not that you really had to notice this, but this is actually one of those multiples of a 3, 4, 5 triangle. So because this side, the 6, is 3 times 2, the B, which came out to be 8, is 4 times 2, and the 10 is 5 times 2. So it's just a multiple of a 3, 4, 5 triangle. Okay, now I can use that my area is 1/2 the base, which remember the whole base is 12, okay, times the height, which we just found out to be 8. Okay, and again, this will give me the 48 square feet. Okay, but again, that's the area of just one of them, so I would have to multiply that by 4. Okay, or 192 square feet. Okay, so that's just 2 different ways I can do this same problem. Okay, I can either find the area using Heron's formula because I knew the length of the 3 sides, or I could actually find the height and then use the formula that you're used to, which is 1/2 base times height.